Hey everyone, my name is Rijita. Welcome back to my channel. I'm from Sri Venkateshwar College of Engineering. I'm studying in Computer Science and Engineering department. And today's subject I will be talking about is discrete mathematical structures, and the subject code is BCS 405A. The topic is function composition and inverse functions. So I will be covering the definitions, properties, and the worldwide applications of function composition and inverse functions. So function composition, the sequential application, that is where one function it is applied to the result of another function. So the notation goes as f of g of x is read as composed with g of x, and the order is in generally where f of g of x is not equal to g of f of x. For example, functions defined as well, let f of x be 2 x plus 2 and g of x be 3x. They are known as the simple linear functions. And a composition of f of g of x is where f of g of x is equals to f of 3x plus 2, which is equal to 3x plus 2. The output of g becomes the input of x, and the composition of g of f of x is where the g of x plus 2 is equal to 3 of x plus 2, which is equal to 3x plus 6. So here the output of f becomes the input of g. So the order impacts here. So we notice that 3x plus 2 it is not equal to 3x plus 6. So this shows that composition order matters. In real world applications, we use it for price calculations such as in markets or shopping malls, etc. So here if we take discount first, so d of x is x minus 0.2x. So then the tax would be, that is t of x is x plus 0.6x. So the result would be t of d of x. We can also use it in temperature conversions like Celsius to Kelvin, Fahrenheit to Celsius, and Fahrenheit to Kelvin. Like for Celsius to Kelvin, we use it as K of C is C plus 273.5, whereas Fahrenheit to Celsius, known as F of C is 5 by 9 into F minus 32. So then Fahrenheit to Kelvin is known as K of C of F. Inverse functions, it is basically the reversal. It is an inverse function which reverses another function. So the notation is known as, if f of x it maps x to y, then f inverse of y maps y back to x. Identity property, it is where f inverse of x is equals to x and f inverse of f of x is equal to x. The one-on-one condition is that a function must be one-to-one injective to have an inverse passing the horizontal line test. Inverse functions, finding the inverse. First step is replace f of x with y. So for f of x, which is 2x plus 3, we write it as y is equals to 2x plus 3. Step 2 is we swap x and y. So the equations becomes x is equals to 2y plus 3. Step 3 is solve for y. So rearrange to y, which is x minus 3 whole by 2. So fourth step is we replace y with inverse f inverse x. So the inverse is f inverse x is x minus 3 whole by 2. For example, the original function where we consider f of x is x cube, and when we swap variables, let y is equals to x cube, we swap to get x is equals to y cube. So now we solve for y. We take the cube root of both the sides, so it becomes y, and x will becomes cube root of x. So the inverse result, thus the inverse function is f inverse of x is equals to cube root of x. So here the composition and inverses verification. So there's the verification goal, that we confirm that f inverse x is equals to x, and f of x is equals to x, and the functions used are f of x is equal to 2x plus 3 and f inverse of x is equals to x minus 3 by 2. F inverse f of x test is that 2x plus 3 minus 3 divided by 2 is equal to 2x by 2 is equals to x. So we confirm that. F of F inverse test is that 2, 2 into x minus 3 by 2 plus 3, which gives us x minus 3 plus, plus 3, which is equal to x. So inverse functions in real world is that inverse functions are crucial in practical applications like encryption and decryption. For example, simple scissor cipher, it shifts the letters by a fixed number of encryption. So decrypting, it involves shifting them back the same amount, that is the inverse, like the unit conversions like Celsius to Fahrenheit, Fahrenheit to Celsius, which have the inverse functions that convert back to the original value. The summary is that first we practice the example to solidify the understanding, then we know about the real world applications, and the key takeaways is that function composition, inverse functions, and their verification. With this, I would like to end the video. Thank you.